This video is covering notes on Introduction to Quadratic Functions. We've already talked a little bit about what a quadratic equation is. So we've looked at ax squared plus bx plus c, and then we factored that. But now we're going to really talk about what actually a quadratic means. And we're going to start off by graphing quadratics. So it's been a while since we've graphed. So what we're going to start off with is the equation y equals x squared minus 2x minus 3. In the last section, we were factoring things that looked like that. But now we're going to look at and see what this looks like on a graph, on a coordinate plane. So to begin, what we're going to do in order to graph, the very basic way that you would graph something is to make a table of values. So I made like a T-chart, but it looks like a triple T-chart. We have our x values over here, which I've picked out the x values for you. It's -2 through 4. And then I have the equation, x squared minus 2x minus 3. So what we're going to do is I'm going to show you the process. If we're making a table of values, we're going to plug in each of these x values and then find the y. So I'm going to go ahead and do that for the first one. Okay, so if I plug in -2, notice that I'm using parentheses in place of x. So instead of x, I'm putting parentheses -2 squared minus 2 times -2 minus 3. Now from here you can use a calculator or you can do this in your head, but when I calculate this, you get -2 squared is positive 4. Then -2 times -2 is another positive 4. So 4 plus 4 is 8, and 8 minus 3 is 5. Okay, so now you're going to do the same thing. I want us to do that for -1, 0, all the way through 4. Okay, so I filled out the table for the process for each of the numbers. So notice that everything's staying the same except for what's in parentheses. That's changing with as the x value is changing. All right, so go ahead and fill that out. And then I want you to plug these in your calculator, do them in your head, and fill out the y side of the table as well. Okay, so once you evaluate each of those, you should get in the y column 5, 0, -3, -4, -3, 0, 5. Okay, now I want you to notice something here. I want you to see that there's a pattern. If you look here on either end, you have 5 and 5. Then working in, you have 0, 0, then -3, -3, and then in the middle you have -4. Okay, when you have quadratics, you have what's called symmetry. And we're going to graph these now. So think of this as the point -2, 5, -1, 0, the point 0, -3, and so on. So what I want you to do now is I want you to take each of those points and I want you to plot them. Okay, so first the point -2, 5 would be here. Then -1, 0 would be here. 0, -3, 1, -4, 2, -3. And notice here's where our symmetry went down, and now it's going back up at the same values. 3 is at 0, and then at 4 we have 5. Okay, so as you can see, what we're creating here is what is called a parabola. So if you were to connect the dots, as you see here, and sorry, my pen is really, really bad. It's really crooked, but it should be a smooth line. Then you get a parabola. All right, so the shape of a quadratic is a parabola. So anytime you have x squared something like ax squared plus bx plus c, then you're going to get some sort of parabola, which is this kind of curve. Okay, so I know this is pretty tedious, but I want you to go ahead. I want you to try to do example 2 on your own. So I've set it up again for you. I've given you the x values in the equation -x squared minus 4x. So I want you to do the same thing that I did in example 1. I want you to do the process, find the y values, then plot the points and graph. Okay, so I want you to pause the video and do that, and then I'll bring it back up. Okay, so here's what your table should look like. So your y values that you should have gotten are -5, 0, 3, 4, 3, 0, -5. And again, you notice that symmetry, that pattern that we had before. And I haven't graphed this, so let me go ahead and graph that. If you haven't, go ahead and do that now, please. Okay, so this is what the parabola should look like. Now, notice that in example 1, our parabola was going up. It was opening upwards. And in example 2, our parabola is opening downwards. Okay, and if you look at the two equations, the big difference that you can see in example 1, if you look at this a, this first value here, that's positive 1. If you look at example 2, you see this a is a negative, that's negative 1. So if a is positive, then the parabola is going to be opening up. If a is negative, then the parabola is going to be opening down. Okay, now something else that I want to mention before we move on is I want to talk about this symmetry again. Okay, so if you look at here, the graph or the table 5, 0, negative 3, negative 4, negative 3, 0, 5. At negative 4 is kind of where the symmetry occurs. So on either side of this line, the values are the same. Okay, and so what we have is if you look at the parabola, you also have this symmetry. So if you were to draw a vertical dashed line down the center, what we're going to call that is the axis of symmetry. Okay, so on either side, you see this point and this point, those are symmetrical from each other. Okay, they're like two values away from this center line. Here, these are symmetrical. Those are 3 values away from the center line. And then here, these are also symmetrical. That's 1 value away from the center line. And then you can see that right here in the middle, this negative 4 point, that's right here in the middle. Okay, so the axis of symmetry is always going to go through that middle point. The same as for example 2. We have this axis of symmetry, so right here at 4, we have the symmetry. So when I draw that on my line here, it goes through the middle point, and on either side of that line, this graph is the same. This point symmetrical to this point, this one with this one, and this one with this one. Okay, so a parabola is always going to have some type of symmetry. Okay, so in this box, this is what I would consider vocabulary. All right, so this is something that's really important with quadratic functions. So a quadratic function is of the form y equals ax squared plus bx plus c. We've learned about that before. And it has a graph that is a parabola, which we've also learned about before. That's the shape of the graph. And then the graph also has a vertical line of symmetry, which we just talked about. So that vertical line of symmetry, if you want to draw that on this graph, we typically draw a dashed line right down the center. Mine's a little off, but we draw a line down the center, and that shows the axis of symmetry. And the axis of symmetry is going to go through that middle point. Now, that middle point right here, right down here, has a special name, okay? And so it's either the highest point or the lowest point of the graph, and the special name that you need to know is called the vertex. We're going to be talking more and more about these words, but for now you need to know that this is some important vocabulary words. And I'm going to go ahead and draw an arrow. So the vertical line of symmetry is this line here, and then the vertex is this point right here. And you see that the line goes through the point. Okay, so now in our first two examples, the way we were graphing these is I just plugged in values. And that obviously gets very tedious and frankly is not very fun. And I'm sure you didn't have fun doing it. So what we're going to talk about is a different way of coming up with the graph of a parabola. Because also in these first two examples, I gave you these x values here. What if I didn't give you those as x values? How would you know which x values to plug in? Well, you don't have to do that. So what I'm going to show you in the next 3 examples is actually the way that I want you to graph parabolas, because they're all going to have some things in common. They're all going to have this general parabola shape. They're all going to have a vertical line of symmetry, and they're all going to have a vertex. Okay. Also, some important things that we're going to look at are the x-intercepts, which are going to be here. Remember, x-intercepts mean on the x-axis, and then also a y-intercept, which is the point which is on the y-axis. So we're going to look at those points. All right, so in example 3, we're going to consider the graph of x squared plus 4x plus 3. And the first thing that we're going to do is we're going to find and plot the y-intercept. Now, hopefully you remember that the y-intercept is when x is equal to 0. So that's important to remember. So if we want to find the y-intercept, we're going to take our equation, which is here. Oh, goodness. Sorry. I meant to draw a box, not a circle. All right, so our equation is x squared plus 4x plus 3. So if x is equal to 0, all we have to do is plug in 0 for x. So when we fill in for 0, we get y equals, and then plug in 0, 0 squared, plus 4 times 0, plus 3. Okay, so this is exactly like we just did with the table. You just plug in 0, and when you do that, you get 3. Okay, so that is our y-intercept. So if we were to plot this point, then we would call this the point. 0 is our x value, 3 is our y value. Okay, so then if we were to plot this, then that would be here at the point 0, 3. Okay, so that is going to be the y-intercept. All right, so now we're going to look and find and plot the x-intercepts. Well, hopefully you remember if the y-intercept is when x is 0, then the x-intercept is when y is equal to 0. Okay, so just like in the first one, we plugged in 0 for x. So now we're going to go back to this equation. We're going to plug in where 0 is y. So if you were to do that, you would get 0 here, and notice what I'm plugging in is in blue and the rest is in red. So you'd get 0 equals x squared plus 4x plus 3. Now, in part A, could just evaluate that. That was simple. But now look at part B. Do you recognize this? Hopefully you do. It's from the last unit. We have x squared plus 4x plus 3. That is the AC method equaling 0. So guess what we get to do? We get to factor. So in order to find the x-intercepts, we have to solve this by factoring. So hopefully you remember how to do that. So using the AC method, A is 1, C is 3. So 1 times 3 is 3, and factors of 3 to make 4 would be 3 and 1. Okay, so this would to make x plus 3 times x plus 1. Now remember, if you set both of those equal to 0, x plus 3 equals 0, therefore x would equal negative 3, and also x would equal negative 1. All right, now when we're talking about x-intercepts, if you look at a parabola, most of the time a parabola is going to have 2 x-intercepts. So when we factor, we get those 2 values. We get the 2 x-intercepts. Now I want to write these as actual points, like I wrote up here in part. I wrote the point 0, 3. That was my answer. So for my answer in part B, we have 2 points. So the 2 points are going to be negative 3. And then remember, we're talking about a point where the y value is 0. So we have negative 3, 0, and the point negative 1, 0. And those are my 2 x-intercepts. So now we're going to plot those 2 x-intercepts. We already have the y-intercept, but now we're going to plot these 2 x-intercepts. So we have negative 3, 0 and negative 1, 0. Okay? Now, those are already 3 points of my parabola. Now, remember that we have a axis of symmetry. Now, notice on this picture up here, we had on either side, we had our x-intercepts here and here. Here's one, and here's the other one. Now notice that looking at the axis of symmetry, the axis of symmetry is right there in the middle of the 2 x-intercepts. So what we can do now that we have our 2 x-intercepts, in part C it says use those x-intercepts to draw the line of symmetry for the parabola. All right, so we know at negative 3 and negative 1 are the x-intercepts, so that means that our axis of symmetry is going to be right there in the middle at negative 2. So I'm going to draw my vertical line to show my axis of symmetry from that point negative 2. And I'm going to make it a little bit straighter and neater, so there we go. Okay, so that shows my axis of symmetry. So now we need just a couple of extra points. So remember, we also talked about this point, the vertex here. If you look at the vertex, remember the vertex is on the line of symmetry. So we could figure out if it's on the line of symmetry, that vertex is going to be at the point right in between those 2 x-intercepts. So that would be at negative 2. So question C asks, what is the x value of the vertex? That's just going to be in the middle of the 2 x-intercepts. So this would be x equals negative 2 is the x value of my vertex. Okay, so now the last question says, what is the y value of the vertex? Because it's at negative 2, but we don't really know where it is at negative 2. It could be at negative 1, it could be all the way down to negative 6. We don't know. So what we need to do is, since that's an x value, we can figure out the y value of the vertex by just simply plugging in, just like we did in part A with 0. So I'm going to plug in x squared plus 4x plus 3. I'm going to put in that x of negative 2 into that equation. Okay, so if you plug in negative 2 into your equation, and again, that negative 2 comes from that x value on that line of symmetry that we found, then if you plug that into our original equation and you evaluate that, you're going to get negative 2 squared is 4, then minus 8 plus 3, you would end up getting -2 as your answer. So that creates a new point. Our x value was -2 and our y value was -2. So now that creates the point -2, -2. And I want you to understand that that's our vertex. So I'm going to label that. That is my vertex. Okay, so that is my answer for question D. And so now we can plot that vertex up here. So it's -2, negative. So that point is going to go right here. Oh, there we go. All right, so now we have 4 points, and now we can start to see the shape of this parabola. Now notice that this axis of symmetry, the vertex is on the axis of symmetry, the x-intercepts are on either side. Now notice we also have this y-intercept. And notice that if we use our axis of symmetry, if we count like the number of boxes it is from the axis of symmetry, we have this one, and then from there we have that, and then 1, 2. You see that's 2 boxes away from the axis of symmetry. So if we go 2 boxes away again, then right here would be our point that is symmetrical to the y-intercept. Okay, so now that we've got these 5 points here, now we can sketch our parabola. I'm okay if we stop there. And now we can sketch that parabola, and hopefully you're doing a better job than I am. I'm just using the mouse of my computer, so that's why my parabolas don't look so good. So this would be the sketch of our parabola. Okay? All right, so I'm going to stop there. I know we have 2 more examples, example 4 and then example 5, but we're going to be doing those in class.